Hey class, welcome to chapter 12 handout 2 answer video. Hopefully you've had a chance to go through it. And you're just here to check up on it. This one was a little bit tougher because it gave you a bunch of information and then had you go back and have to dig through it. But we'll run through it real quick here. Let me get my screen shared and we'll get started. Okay, so the first thing you'll notice here, it says up top, all scenarios are independent of other scenarios, and since all cash flows are after tax, then everything that is numbered is just a scenario. So number 1's about Cambry Day, number 2 is about Wilma Golding, number 3 is about David Booth, and number 4 is about Patsy Folsom. Then you get down to the bottom where it has the extra stuff. That is where the questions start. Okay, so what is the payback period for each of Cambry Day's projects? Okay, so Cambry Day here is number 1. The first thing we do is payback. Okay, so we have our investment here of $20,000. How long is it going to take to get it back? Okay. Well, we look at project A. After 2 years, we've recovered $14,000. We still have $6,000 to go. We are going to get that all in year 3. Okay. But if we take that $6,000 and we divide it by 10,000, it's 0.6. Okay, so we need 0.6 of a year here. So for project A, it's 2.6 years. Project B, well, look, it's 6, 8, 10. It's the same. It is the exact same, 2.6 years. So project A and project B have the exact same payback period. If a rapid payback is important, which project should be chosen? Well, you're going to get in 2.6 years no matter which one you choose, right? So just given this information, and you knew that the payback period for each of these is 2.6 years, you really do not know which one to choose, do you? It's one of those limitations on that payback period. It says which project, which one would you choose? Well, with just that information, I don't know. But then the next question, it says, which should be chosen? Okay, that was first one. Here we go. Number 2. Which of Cambry's projects should be chosen based on the ARR? Okay, so remember to find our ARR. It's average income divided by our investment. Okay, well, first thing we need to do is find our average income. Remember that these are expected cash flows. The project is depreciable. So depreciation equals 20,000 divided by 5. Just always use straight line. So it equals 4. Oops, we'll just do 4,000 per year. Okay, so then for net income, we have A for years 1, 2, 3, 4, 5. And then underneath we'll say we'll have an average. So project A, what we need to do is take our cash flows minus the depreciation. Okay, so for A, 2,000, that is for 6,000 minus 4,000. Okay, so what we're doing, we're taking our cash flows minus depreciation, get our net income. So in year 2, we have 4,000 here, and then we have 3 years of 6,000 for project A. For project B, the first 3 years are exactly the same because the cash flows were the same. Then we look at our cash flows for year 4 and 5 are 3,000 minus the 4,000 depreciation. So we're actually losing $1,000 here. So if I were to add all these up, 6,000, 6,000, 6,000 is 18,000 plus 4 is 22, plus 2 is 24. 24 divided by the 5 years gives me an average net income of 4,800. Over here, I got 6 plus 4 is 10, plus 2 is 12, minus the 2,000. So I got 10,000 divided by 5 years, 2,000 per year. Okay. So project A's ARR, we would have 4,800 divided by 20,000, 24%. For project B, it's 2,000 divided by 20,000 for 10%. So if we were looking at the ARR, we would want to go with project A on this one because it is providing a higher return. Okay, taking into account those last 2 years. The payback period, project A and B, they both started off great, but A finishes stronger. All right, so let's scroll on next one. So I'm going to take this time, and hopefully you're watching the videos, to explain the difference between an annuity and a present value of 1. So an annuity is a payment of equal amounts that happens on an equal basis. So maybe you're getting $50,000 at the end of the year, every year for 20 years. So the payment amount's the same, 50,000. And at the end of the year, boom, you get paid. It's at the same time every year. And it's constantly. Okay, it doesn't have to be yearly, could be monthly. Maybe it's a $2,000 a month annuity. Okay, whereas the other ones are just one-time events. Okay, so that kind of explains the difference between the present value of 1 and the present value of an annuity and why we need different formulas. But here is kind of a practical use of this future value present value stuff. Okay. Says, assuming that Wilma Goldberg will live for another 20 years, should she take the lump sum or the annuity? Well, what happens up here? Looking right here. Wilma Goldberg is retiring, has the option to take a retirement of a lump sum of $450,000 or to receive $30,000 per year for 20 years. The required rate of return is 6%. Okay, so we could have $450,000 today, or we get $30,000 payments. The 20 times 30,000 comes out to $600,000. So you're thinking, wow, I could take 450,000 today, or I could get a total of 600,000 over 20 years. Of course, maybe I should take it over 20 years. But what we really need to do is take those payments at $30,000 per year for 20 years, and let's discount it back to find out how much is that worth today. Okay. This is an annuity because it's 30,000, the same amount once a year. So on equal basis every year. So if I wanted to find this, I could take present value equals the payment times the factor. And when I'm doing the factor, I am going to make sure I am using the annuity chart. Okay. So in this case, our present value equals 30,000. And if I went to the fact and found a factor on my annuity chart where my I equals 6, okay, because she wants a 6% return, and my N or my time period equals 20, I got a number of 11.46992. And when I multiply them out, 344,098. Okay, so those payments have a present value of $344,000. They're only worth $344 today, whereas she could take that lump sum of $450 today. So here you would actually want to take the lump sum payment. Because that means that if she took that $450,000 and invested it and got 6%, like her required rate of return is, she would be able to withdraw more than $30,000 per year for the next 20 years. That's basically what this is telling us here. Okay. Next, David Booth. Ooh, I don't want to do that. Actually, making it smaller would be even better. Wow, that's because my page here is ending. All right, so David Booth is interested in some tools, independent drywalling. Cost of the tools and the equipment is $30,000. Tools and equipment, okay, ready to return. So we're gonna do a net present value. Okay. Our I here is going to be 8, and our N is always going to be whatever period we're in. Our initial investment here is $30,000. It tells us that for 6 years, we're going to get $9,000 returned each year. Okay. So what I need to do now is I need to use my chart, my present value of 1, okay? Because I'm going to look at each of these ones individually. Okay, so when I'm looking at them individually, not as a series of payments, I use my present value of 1 chart. I use year 1, so my time period, my N would be 1, my I would be 8. For year 2, my N would be 2, my I would be 8. Okay, you would match them up, get those factors, multiply them by the $9,000. Okay, I am not going to write all the factors out there. But when you multiply them out, these are the numbers you should get. And then if you were to add those all together, you would get a 5933 net present value. Yes, do the project because it's higher than 0. And finally, Patsy Folson, to find the internal rate of return, we take the investment, 400,000, divided by the yearly cash flows, in this case, the savings, 75,000, we get 5.333. Let's write another one on there. It's 10 years, so we would go to our annuity chart. We would look at the 10-year column. We would go across until we found one. And this time, I believe 13% was like 5.4, and 13% was 5.2, 14% was 5.4. So I said this was 13.5% from matching it up on that annuity chart. And so there's how you do those. Hopefully that's helped you in the book and the PowerPoints and the other lectures to be able to get through this chapter, get that homework done, get through test 2, and we only have 4 chapters, 2 tests remaining. Keep up the hard work. I'm very proud of everything you've done this 5-week class. I know it's not easy, so I really appreciate you sticking it out. Have a great day.